First, I'd like to thank the committee for allowing us to have the opportunity to share our research here at Uruguay. The project that we have is going to be a little controversial to some because we have had differences in opinions, and I've had some good discussions going on. And pretty much what we were looking at for this, that's what happens when you're short. They have to rearrange everything. One of the biggest issues we have in the beef industry in the U.S. is actually variation of the end product. So this is a major challenge in the beef industry. And one of the things that we were wanting to look at, trying to capture what was changing this, causing some of this variation, was temperament. And we were looking at a set of animals that were relatively consistent. Now, if you look at the data that's in the literature, you will find that temperament has affected average daily gain, impacts the incidence of dark cutters, and has also had an impact on tenderness. So what we were wanting to do is to see if we could develop what we call a chute side measurement. We wanted to be able to go to the rancher and say, okay, this is what you can do to say this animal is temperamental, and it would be an objective one as opposed to this subjective that has been used quite frequently. So one of the things that we brought into this was small little blood lactate meters. These are used by runners and trainers in the human end to monitor blood lactate. And we were thinking that these animals that are temperamental will have a higher level of blood lactate. Therefore, it would be something we could use to identify these animals. So when we were looking at this, we had Simmental Angus steers. They are all from the same ranch. They'd been handled the same way all the way through. After weaning, they were moved to the Chapel feedlot in Nebraska, which is, for anybody who doesn't know, that's a 10-hour drive away from where we are. So we were looking at temperament, and we measured these in different ways, mostly because we wanted to capture what was already done, but also see if we could utilize our newer version to utilize this. So we looked at it at weaning, so that's right when they were taken from the cow. 2 weeks later at revaccination, roughly 2 weeks later at feedlot entry, and then when this specific feedlot actually does ultrasound to determine when to market the cattle, so we were doing it at that time. So when we're doing this, this has been put in when everybody else, when they're already being handled. So there are a few constraints that occur in this because of that. We had to be able to deal with what was already in place. So when we looked at average daily gain, we actually looked at the weight that was at midway through the feedlot, and it was that should be adjusted weaning weight that was used, and that there was 140 days from weaning to that midway term. One of the more common methods that are used by breeders in Montana, at least, is the use of docility scores. And this docility score that we actually used is kind of a modification of Dr. Grandin's. The Beef Improvement Federation has developed one that has a 6-point scale. It's slightly different than some that you will see in publication, but this is the one they were using. So basically 1 is docile, 2 is restless. There's a big long description with those, and if you want, the description are actually in the paper. Restless, nervous, flighty, aggressive, and very aggressive. And for the aggressive, basically that would mean you are heading for the fence when they turn around. We were also looking at this blood lactate approach. So we took the small blood lactate meter, and from the ear, all you need is 1 drop. It looks a lot like an insulin meter. So all you need is 1 drop, and we took it from the back of the ear, and you can see Caitlin working on it at this time. There was a cat, they were caught in the head chute, and we would just take that little drop of blood and use it to analyze blood lactate, and it would report it as millimoles per liter. The other one that is very effective and has been used in Texas, Australia, and some other countries Texas isn't really another country unless you're from the U.S., and you might think it is. So when you're looking at it, we were looking at how fast they were moving. And in ours, this, you can sort of, this eye, oops, I can't get the mouse to, there it is. This is the second eye for the stop gate, and there's one 6 foot before that, and we actually had it 6 foot from the, which is 2.54 meters. No, that's the wrong translation, but 1.82 meters in front, and then 3.64 meters in front of the chute. Mostly we needed that extra space because there's a lot of places that they were wanting to do it right out of the chute, but because we were at a working facility, we had to give them that space. Otherwise, they were always setting it off in the cow. We weren't getting the cow measurement, we were getting the person's measurement, and let me tell you, the people were actually a lot slower than the cows. So when we look at the statistics, we did measure individual steers. All of the all 154 were measured. And when I went to analyze this, we needed classifications for growth rate, the growth rate, lactate, exit velocities for statistical analysis. So when we did this, I took all of the data, put it through an Excel spreadsheet, determined what the mean was and the standard deviation. One standard deviation above the mean was considered high. One standard deviation below the mean was considered low, or slow. So that's how we came up with the classifications for temperament. And we used the general linear model. LS means was used to calculate the means due to the unequal number of observation. And trying to make this as conservative as possible, we used the Dunnett's test to separate our means. When you have unbalanced data, especially in that middle range, there was a lot more animals than there were in the top and the bottom. And we did Pearson correlation on all data. So if you look at what happened in this data, we did get, this is not really surprising because we classified them that way. So it's good to see that when my classification actually worked, there was a significant difference in average daily gain between your fast, medium, and slow. And with no surprises with that growth rate, you have a larger carcass weight. And we had a tendency, it wasn't significant, but you had a tendency to have a slightly larger ribeye. And we had less fat in the faster growing animals. These could possibly be due to the fact that they hadn't actually reached the top of their growth curve. The yield grade, for those of you who are familiar with the U.S. yield grade system, because you have a difference in fat thickness, you're going to expect a difference in yield grade. Now the more interesting stuff occurs right down here with your exit velocity, and this is where when you do research and it doesn't come out the way you expect it is, then you start having to figure out what happened. This is one of those times, if you look at most of the other data, the guys that left the chute rapidly, especially if you look at the information out of Australia, those animals were normally slower growing, and in our data set, it's just the opposite. Now there's some options here. Some of the data that is reported in the literature, a lot of that is done at a research institute in their feedlots. Now this is actually done at a real feedlot in Nebraska, and my thought process here is that we have those that are slow are a little more timid, and they're not actually pushing into the feed bunk and being able to get the feed that they need. So that is kind of our take on that. Now when you look at correlations, you know, these tables, you have to study them forever. So we're going to hopefully, if I did this right, we're just going to highlight a few of them. There is correlations, relatively strong correlations on ribeye area for carcass weight, for average daily gain, and there is a negative correlation between ribeye area and fat thickness. As expected, there is a major correlation between the components of the yield grade equation, which would be ribeye area and fat thickness. So we expect that to occur. If it didn't, I'd have been probably not showing the data. Now, if you look at the effect of the different measurements, now this is actually the average of the 4 measurements. So the CS average is the shoot score average for the 4 periods. The exit velocity average is EV AVG, and blood lactate average is in there as the BL AVG. There are no true significant differences there, but we have a couple trends there. They're not very strong, but we are starting to see some impact on carcass weight, some slight suggestion there might be an impact on fat thickness. And as I indicated earlier, this is my data has absolutely no relationship to what's been seen in Australia, where they've seen a relatively strong correlation or effect of temperament on average daily gain. And if you look at those numbers there, it doesn't even come close. So it is definitely not a factor. And the last thing I wanted to show you is the correlation between the different temperament measurements. One of the main things we wanted to have there is blood lactate related to the existing measurements that are used. And you'll notice that the blood lactate is not a real strong one, but there is a relationship, and these are very similar to correlations that have been reported between shoot score and exit velocity. So we're kind of in that same region of ability to use it. Now, these are relatively easy to use. None of those measurements are difficult, except for maybe not having the same person being there to do your shoot scores. And then we also have to take into consideration a lot of the shoots that we have in Montana anyway. They're what we call silencer shoots, and they do have a tendency to use the squeeze, so the shoot score can be influenced by that. So the one thing that we saw was steers with slower exit velocity had lower average daily gain and a lower carcass weight. They also had a smaller ribeye area, and this was also negatively correlated to fat thickness and yield grade. Our blood lactate concentration correlated with exit velocity, but had no relationship to carcass data at all. So we weren't seeing what we really wanted to with the use of that blood lactate meter. What we did see, though, and it supports some of the other data that's in the literature, that exit velocity is a much better predictor of the effects on carcass characteristics and growth rate, the temperament, so that you can utilize that as well. I'd like to acknowledge the cooperation of the Chapel Feedlot, American Simmental Association, and the funding of Bear Ranch Foundation.